All right, let's do example 3. This is commonly known as the dis method, and we'll see why. So all the next two examples are going to involve revolving some two-dimensional region around the x-axis. So let's see. So we're going to compute the volume of the solid generated by revolving the region bounded by y equals the square root of x. So this, y equals 0, which is the x-axis, and let me change this actually to x equals 1. Because this is telling us where to stop here. Okay, so this is x equals 1. All right, so this is the region we're talking about. We're revolving it around the x-axis, so we're just spinning it. So if you've ever worked with, I don't know, a lathe or something like that, sort of think that. And this region's going over here. And so what is kind of cross-section are we getting here? Well, we're getting a circle. So this cross-section, right? So this is some sort of, sort of like the nose cone of an airplane or something like that shape, right? So we're spinning this shape here around and filling in all the space. And so the shape we get as our cross-section is a circle. And then remember, the area of a circle is pi r squared. And so all we need to know in this case, since we have a solid circle, is what is the radius of this circle, right? And so we know that it's centered at y equals 0, but what is the length of this? So we're going from 0 up to, at each x value, we're going up to the square root of x, right? So this is going up to the square root of x. So the radius of this circle at each x value is the square root of whatever that x value is. And so the area function, a of x, is equal to pi r, in this case, is the square root of x, and we square it. And remember that we're going to compute the volume, we're going from a to b, area function dx. Okay. So this is that function. Let's also notice that we can simplify this to just pi x, because the square root of x squared is x. Okay, so let's take all of this over here. We're going to compute the integral of pi times x dx. And our bounds, we're going from 0. And then, so the next question is, what is this bound? So we have, well, I guess we already know, because it's telling us exactly that it stops at x equals 1. So this bound has to be 1. We don't need to do any computation, so we're going from 0 to 1. I'll take this pi out as a constant. Take the antiderivative, 1/2 x squared from 0 to 1. We'll take the 1/2 out, so we get pi over 2 x squared from 0 to 1. And so pi over 2, 1 squared minus 0 squared equals pi over 2 times 1. So it's just pi over 2.